In this demonstration, we're going to take a look at how to conduct a correlation using two scale variables. So this is a bivariate correlation, and we are going to use two scale variables. And the two variables that we are going to use are hours slept, which is a scale variable, and the mood, which is a scale variable because it's based on a rating on a scale of 1 to 10. So if we go into data view, we see that we have hours slept by our 5 participants, 5, 7, 8, 6, 6, 10, and the mood next day of 2, 4, 7, 2, 3, 6. So these are all pairs. So person number 1 slept for 5 hours, has a mood of 2. Person number 2 slept for 7 hours, has a mood of 4, etc. We want to know if there is a significant correlation, and we will be able to determine the strength and the direction of the correlation, as well as produce a visual representation through a scatter plot. So let's go ahead and take a look at these two variables, hours slept and mood, in our correlation. We go to Analyze, Correlate, Bivariate. That means two variables. We are going to use the two variables called hours slept and mood. Let's look at the options, see what we can see. Yeah, we can do means of standard deviations, that's fine. And let's leave everything else alone. We don't need to worry about covariance. Continue. The correlation coefficient that it's going to produce is Pearson's R. That's good. The other two are reserved for special situations that we're not going to cover here. Our test of significance will be two-tailed. We aren't going to make a one-tailed test out of this right now. We're just going to look at the two-tailed test to see if there is a significant difference anywhere. And this is a nice button. It says flag significant correlations. Wouldn't it be nice if in SPSS it always asked if you wanted to flag significant results? In this case it allows us for correlations, but wouldn't it be nice if it did it for ANOVA and independent sample t-test, etc.? Well, it doesn't. You just have to use your brain. Alright, we click OK. And our output produces some interesting findings. We have hours slept. The average hours slept, or the mean hours slept among those 5 participants is 7. Or excuse me, there are 6, they're not 7, they're not 5. So among the 6 participants, there are the mean hours slept is 7. The mood on average, or the mean mood, is 4 for the 6 participants. Now, we get a correlation box that has some redundant information. Really, you'll need to look at the top column, or the top row. So for hours slept, it'll tell us a Pearson correlation for mood. So mood goes down the column. Hours slept goes across the row in this case. So if we look at hours slept, the Pearson correlation for hours slept and hours slept is 1. It does it as a square, and when you do it as a square, it will correlate the variable to itself, which will always be 1. It's non-information, really. The hours slept to mood, the Pearson correlation is 0.853. It has an asterisk there, which means that the correlation is significant at the 0.05 significance level. And our two-tailed significance is 0.031, which we know to be less than 0.05, which means that it is significant, even if we didn't realize that from looking at the correlation coefficient. So here's what we have. We have a correlation coefficient of 0.853. That is a positive number, so that we know that the correlation itself is positive. That as one variable increases, so does the other. We are able to determine the strength of that correlation, mostly relying on the fact that it is significant. And if it is a significant correlation, then it's probably a strong correlation. So we have a strong positive correlation. Without getting into a lot of details, there are other ways to determine the strength of the correlation, but again, we're not going to get into that in this course. There are 6 people in each group. Well, we also want to look at this graphically. So in order to produce a scatter plot, we go to Graphs, Legacy Dialogues, Scatter Dot. I make sure that my simple scatter plot is checked, and I click Define. It really doesn't matter which variable goes on which axis, but for the sake of convention, we're going to put the variable that we think is leading to the change in the other variable in the x-axis. So the variable that we think is leading to a change is probably hours slept. We probably think that hours slept is impacting mood somehow. even though we know that mood can impact sleep itself. So we're going with just kind of a working model that says that your sleep affects your mood. I know it does mine. So sleep, or hours slept, is on the x-axis, which is said to lead to a change in the y-axis. Now, if I go to options, I don't know if there's anything that's interesting here. No, not really. And everything else can just be left alone. So let's go to OK and look at the visual representation for our data. So here's what we have. We have hours slept on the x-axis. It starts at 5 because that's the lowest number that actually occurred. And it goes up to 10 because that's the highest number that actually occurred. SPSS does that as a way to produce graphs and charts that have minimal excess. We would like it to go all the way down to 0, and we could ask it to go down to 0, but for the sake of this, we'll leave it alone. It's fine how it is. And mood starts at 2 because that's the lowest mood reported, and goes up to 7 because that's the highest mood reported. Again, for the same reason, it restricts the range so that you don't see a lot of excess space. Now, you can see that the trend of these dots is positive, so we can clearly see that there's a positive correlation. And based on what we know from the data, it is a strong correlation, but we can't really see that here. We can probably assume that maybe it's strong because if we drew a line that kind of split through all of those dots, we can see that many of the dots, really all but these two, probably fit on that line. So I guess I could show you what a line of best fit would look like here so you can kind of visualize where most of the points tend to fall. So you don't have to do this, I'm just kind of showing it to you because I can. So this is a line that tells you where the average of all the lines, or of all the points, would be. So this is kind of like the line that represents the mean for all of these. So this point located at 8 over and 7 up is so many units away from this line, and this is the distance that we are calculating in order to determine the standard deviation of these points. Now, some of these points don't vary from the line at all, so that's why we have some strength here. So for example, these 3 points don't vary at all from the line, and this point does only by a little bit. And this one's kind of in the same neighborhood, so it's not too far away from the line. This is the only point that really varies a good amount. I was going to say significant, but we don't want to mix terms up. So this is a visual representation for what we found. In our correlations box, we have a positive, strong correlation that is significant. I look forward to seeing what you can do, and let me know if you have any questions.